we are in chapter 5.1 and we're going to be working with ratios. So a ratio is a quotient of two quantities. It can be represented in three ways. The first one is said as 1 to 2, or we can say 1/2, or we can say 1 to 2, but this time instead of writing the word 2, we're actually using the colon. So how do we write ratios as a fraction? The order of the quantity is important when writing ratios. To write a ratio as a fraction, write the first number of the ratio as the numerator. So the first number they give you will represent your numerator. And the second number will be your denominator. So here's an example. It says write the ratio 15 to 23 using fractional notation. Well, the first number we have is 15, so it goes in our numerator. The second number is 23, so it goes in our denominator. And we have 15 over 23, or 15/23. Here's another one. It says write the ratio of $25 to $15 as a fraction in simplest form. Well, the first number we have is $25, so it goes up top. The second number we have is $15, so it goes on the bottom. So now we must write this in simplest form. So we can divide both by 5. It will end up with 5/3, or 5/3. Write the ratio of 2.6 to 3.1 as a fraction in simplest form. Well, again, the first number we have is 2.6. And the second number we have is 3.1. Okay, now because this fraction contains decimals, we must simplify the ratio as a ratio of whole numbers. So 2.6 must be written as a whole number, and 3.1 must be written as a whole number. Notice that they both contain only one decimal point, or decimal place. So what we're going to do is multiply the top and the bottom by 10. Remember the rules of multiplying by 10? It moves the decimal one place to the right, and it'll also do the same for the bottom. Now I'm allowed to do this because I'm multiplying the top and the bottom by 10. So 2.6 times 10 will give us 26, and 3.1 times 10 will give us 31. So this fraction, 26 over 31, is the same as saying 2.6 over 3.1. Let's make up another example real quick. Let's say we had to write the ratio of 2.65 to 3.14. Okay, so let's do the same thing again. The first number we have is the 2.65, and we're going to divide by 3.14. Now again, we have a fraction with decimals, so we know we're going to multiply by a power of 10, but which power of 10 will it be? How many decimal places does each decimal have? 2. So I want to multiply by 100. It has 2 zeros. And because it has 2 zeros, remember we know to take the decimal point 2 places to the right. So this is going to become 265 over 314. And this is in simplest form. So we can say 265 over 314 is the same as saying 2.65 over 3.14. Okay, here's another example. Now we have mixed numbers. It says write the ratio of 1 1/5 to 2 7/10 as a fraction in simplest form. So we have 1 1/5 over 2 7/10. Now, just like the previous example where we had decimals, we also cannot have mixed numbers inside of our fractions. So the first thing we're going to do is take each mixed number and write it as an improper fraction. So remember, to do that, it's going to be 1 times 5 plus the 1 in your numerator, which makes it 6. Keep the 5. So we have 6 over 5 divided by 2 times 10 plus the 7 in your numerator, which makes it 27 over 10. Now, again, we still cannot have our improper fractions like this. This is what we call a complex fraction. So remember the rule or the method: if we have single fractions in the numerator and the denominator, we can rewrite it using the divide symbol. So 6 over 5 divided by 27 over 10. And then remember, we do not divide fractions. Instead, we multiply by the reciprocal, which is the flip. So keep the first fraction and then multiply by 10 over 27. Now we can simplify. So we can take the 6 and the 27, divide both of them by 3, and the 6 will become 2, and the 27 will become 9. Then we can do the same to the 5 and the 10, divide both by 5, the 5 will become 1, and the 10 will become 2. So now we end up with the fraction 4 over 9. So when writing ratios as fractions, remember, you cannot have decimals in your fractions, and you cannot have mixed numbers in your fractions. Okay, it says, given the rectangle below, or shown, part A says find the ratio of its width to its length. So its width to its length. So first of all, which is the width and which is the length? The 7 represents the length, and the 5 represents the width. So we want the width to come first, which means the width will be up top. So we have 5 feet divided by its length, which is 7 feet. Now, because we have feet divided by feet, they cancel each other out, and we're left with just 5 over 7. That's part A. And then part B says find the ratio of its length to its perimeter. So the first thing we got to do is find the perimeter of this rectangle. So remember, perimeter is equal to adding up all the sides. Well, if this is 5 feet, this is also 5 feet. And if this is 7 feet, this is also 7 feet. So you're going to do 7 plus 5 plus 7 plus 5, and you should get 24 feet. So the perimeter is 24 feet, and it says write the ratio of its length. So the length will come first, and the length was 7. So 7 feet over its perimeter second, and that was 24 feet. And remember, the feet over feet cancel each other out, and now we just have the fraction 7 over 24. Okay, a special kind of ratio is called a rate. A rate is used to compare different kinds of quantities. So for example, we have the ratio 3 miles to 33 minutes. So you can, let's say, run 3 miles in 33 minutes. Now remember, we can simplify the 3 and the 33 by dividing both by 3. So if we divide 3 by 3, we get 1. And we divide 33 by 3, we get 11. So in simplest form, this is the same as saying 1 mile in 11 minutes. So you can run or walk, whatever it is, 1 mile in 11 minutes. So it says write the rate as a fraction in simplest form. Now remember, a rate is the same as a ratio. The only difference is now you are comparing different quantities. So it says 10 nails every 6 feet. Well, the first number they give you is 10 nails, so that goes up top. And then the second number they give you is 6 feet, so that goes on your denominator or on the bottom. Now, of course, we can simplify this by dividing both by 2. When you divide 10 by 2, you get 5. And when you divide 6 by 2, you get 3. So this is saying 5 nails every 3 feet. The nails and the feet do not cancel out since they are not the same. And this will be your final answer. When we did ratios before, our units canceled out because they were just alike. When we're doing rates, your units do not cancel out. Here are some more examples. It says write each rate as a fraction in simplest form. Number 1 says $2,160 for 12 weeks. So the first number they give us is $2,160. And the second number they give us is 12 weeks. Now, of course, we can simplify this by dividing both by 12. We end up with $180 in 1 week. Again, your units do not cancel out, so we keep our dollars and we keep our week, and this is your final answer. All right, number 2. It says 360 miles on 16 gallons of gas. So the first number we have is 360 miles. And then the second number is 16 gallons of gas. We can again simplify by dividing both by 8. When we divide 360 by 8, we end up with 45. If we divide 16 by 8, we end up with 2. So now we have 45 miles on 2 gallons of gas. So you work problems of rates the same way you would with a ratio. The only difference is your units do not cancel out. Okay, so now a unit rate is a rate with a denominator of 1. So for example, when you're driving, your speed could be 55 miles per hour. So how would you write that? 55 miles goes up top. Then on the bottom would be the 1 hour. And this is a unit rate because your denominator is a 1. So you're saying in 1 hour, you should be able to go 55 miles. Now, how do you write a rate as a unit rate? To do so, you're going to divide the numerator of the rate by the denominator. Divide the numerator by the denominator. It says write as a unit rate. We have $31,500 every 7 months. So first, let's start by writing it as a rate. The first number we get, or have, is $31,500 every 7 months. So this is the rate. Now, in order to get the unit rate, we're going to divide the numerator by the denominator. So numerator on the inside, denominator on the outside. And we got 7 into 31 4 times. And we end up with $4,500 every month, or 1 month. So in a month, you should have $4,500. This is the unit rate because we have a 1 in the denominator. Okay, let's practice some problems. Let's go in our book to page 361. And we're going to look at numbers 39 and 41. It says write each rate as a unit rate. In 39, it says 375 riders in 5 subway cars. So 375 riders and 5 subway cars. The first number we have is 375 riders. And then the second number we have is 5 subway cars. So this is the rate. Now, in order to write it as a unit rate, we're going to take our numerator and divide it by our denominator. So 375 divided by 5. So now our numerator is now going to become 75 riders. Per 1 subway car. So you can write it as 75 riders per subway car. All right, number 41. Now it says a hummingbird moves its wings at a rate of 5,400 wing beats a minute. Write this rate in wing beats per second. So the first number we have is 5,400 wing beats. And it says a minute. So in the question, they want us to write it as per second. So for now, I'm going to write 1 minute. And I'm going to rewrite this, because even though this is a unit rate in terms of minutes, they want it in terms of seconds. So this is 5,400 wing beats every 60 seconds. Because remember, there are 60 seconds in a minute. Now, this is our rate. And we need to write it as a unit rate, so we're going to do 5,400 divide by 60. And we end up with 90. So 90 wing beats per second. Okay, now using unit rates, we can also find a unit price. How do we find our unit price? Well, we're going to have the price divided by the number of units. And then, just like before, we're going to take the price and divide it by the number of units. So we end up with a unit price. So numerator is still being divided by the denominator. So it says a store charges $4.80 for a 32-ounce container of laundry soap. What is the unit price in dollars per ounce? Now, when you go grocery shopping or any store and they actually sell things, you can look on the tag and it actually tells you the unit price. So the first number we have is $4.80. So that's up top in our numerator. And then the second number we have is 32-ounce container. So we have 32 ounces. And we must write this as a unit price. So we're going to take our $4.80 and divide it by 32 ounces. So the unit price would be 15 cents per ounce. And you would write it as 15 cents per ounce. It says approximate each unit price to decide which is the better buy. Is it better to buy 4 bars of soap for 99 cents or 5 bars of soap for $1.19? Okay, so we have two different unit prices to find. The first one says 4 bars for 99 cents. So remembering your unit prices, the price goes up top. So there's our 99 cents for 4 bars. And then for the second one, we have $1.19 for 5 bars. So even though they switch the orders on your numbers, be careful. The price goes up top, the number of units go in the denominator. Now we need to divide it out. So we're going to have 99 cents divided by 4. and we get 0.2475. And we're going to do the same thing. $1.19 divided by 5. And this one becomes 0.238. Now, which is the better buy? Is it better to buy the 5 bars for $1.19 or the 4 bars for 99? Well, which one has the smaller unit price? This is the smaller unit price. Therefore, it is cheaper or better to buy 5 bars for $1.19. Okay, let's go back in our books now to page 363. And let's start with number 57. It says find each unit price. And it says $57.50 for 5 DVDs. So the price goes up top, which is $57.50, divided by the number of units on the bottom, which is 5 DVDs. Now, because it's a unit price, we have to divide the numerator by the denominator. So $57.50 divided by 5. And we end up with $11.50 per DVD. All right, let's try number 63. Now it says find each unit price and decide which is the better better buy. Round to 3 decimal places. Assume that we are comparing different sizes of the same brand. So number 63 says frozen orange juice. We can buy 16 ounces for $1.69, or we can buy 6 ounces for 69 cents. So we want to know which one is the better buy. So we have $1.69 for 16 ounces. Or we have 69 cents for 6 ounces. Okay, so I ran out of room but hopefully you're also working this. And it said round to 3 decimal places, so this would be 0.106. So the unit price for this one is going to be 0.106 per ounce. Now we also got to find the unit price of this one. And this one becomes 0.115 per ounce. So now which one has the better unit buy or the better buy? Look at your unit prices. Which is smaller? Is 0.106 or is 0.115 smaller? The answer should have been this one. Therefore, it is better to buy 16 ounces for $1.69. Okay, so this will conclude our video for 5.1. If you have any questions, please email me.